Hello everyone, welcome to the video report of Group 6 from BSIT 3A SMP. In this video, we are going to discuss about the ethical decisions in software development. Now, you must already know what is ethics. Ethics refers to dealing with morals or principles of morality pertaining to what is right and what is wrong, meaning it's a manner of behaving based on a rules or standard that people set as a proper behavior or practice. But why do we exactly need to know what is ethics? It's because ethical decision making refers to the process of evaluating and choosing among alternatives with ethical principles. To simply put it, we must first be aware of what ethical issues that the developer may encounter regarding software development process so that we can be able to create a software quality. A software quality is defined as a field of study and practice that identifies the desired characteristics of software. So this software quality, it helps to avoid wasting time and money. A software quality also helps to uncover mistakes or defects in a software code or designs throughout the whole development process. Thus, it guarantees that the final product or the final system is competitive, secure, and fulfills its functions that the end user needs. To make it more simple, a software quality is like the general standards that a developer uses in order to develop a high quality software system. Now, how do we identify if a software system is of high quality? Well, a high quality software system are systems that are simple to learn and use because they can execute fast and efficiently and can also satisfy the needs of the users and operate safely and reliably, resulting to minimal systems downtime. So this we can identify if a software is of high quality if already should have a quality management system, if it should have been already subjected to software defect testing, if the developer had already been addressed some ethical issues and had a software liability. Now, if all four of these steps or pace have been completed, then the software that you developed or the developers develop is no doubt as a high quality software system. Now let us fully understand these steps. The first one is the quality management. The goal of quality management is to define, measure, and improve the quality of the development process and the products that is created at each step. Meaning, the quality management's goal is to assist the developers in producing a high quality systems that is suitable to the end users. Unfortunately, sometimes a software system usually doesn't really function as well as its users wants it to until it has been used for too long, and then the developers discovered that the system is still lacking in some areas. That is how a quality management works. Now the second phase, let's move on. The second phase is the software defect. Any error, if not corrected, could cause a software system to fail to meet the needs of its users. or could cause the software to crash, and this is what we refer to as a software defect. For example, you are a customer of an online shop. Their application indicated that they accept an online payment or e-payment, but then when you were about to pay, the options of selecting the e-payment is missing. Therefore, the software has a defect. But what's more troublesome than this is there are some software defects that are far worse than the situation. There are some software defects that can even damage the end users. And this is where the software liability comes. So what is software liability? If the software defects can cause the end users some damage, the software liability is like the guarantee that the developers is responsible to this. A software liability makes a software developers think about implementing changes. Liability obligates developers to secure the information entrusted to them. Liability implies that people in the best position to solve the problem are also the ones who are liable for it. To simply put it, always remember that a software is a product that the developer sells. So as the creator of the software system, the developer is also the one who is responsible if the software system causes harm or damage to the end users or the customers. That is how a software liability works. Now, the ethical issues will be discussed with my other group member, Hannah.
Example of ethical issues in software development. First, we have addictive design. Second, corporate ownership of personal data. Third, algorithm bias. Fourth, weak cybersecurity. And fifth, overemphasis on features. Addictive design. Every developer wishes to create applications that users enjoy using. The issue is that some teams create apps that consumers adore. The involvement of digital platforms such as social media has raised ethical concerns. As long as social media companies profit on anger, confusion, addiction, and unhappiness, our well-being democracy are at risk. Say critics like Harris of the Center of Humane Technology. While working at Google, Harris' presentation on the push of addictive technologies, design, and firms' moral duty in society went viral, striking an ethical balance between things that people enjoy and products that take their attention is more of an art than a science. When designing or modifying a product, consider the following questions. First, who stands to gain? Second, what are the advantages? Third, how much do they gain from it? Compare and contrast popular apps like Duolingo and TikTok to examine the addictive design, suggests David K. Bain, Vice President of Standards for the Telecommunications Industry Association. Both apps aid in the expansion and profit of their producers, but the nature of the benefit to consumers differs. User data is gathered for corporate use, and machine learning techniques are utilized to improve the program. The term transparency relates to how much information and understanding users have about these actions. Here's how the two apps in question deal with the ethical dilemma. The two apps have opposing viewpoints on usage limitations intended to prevent addictive attachment. Duolingo promotes consistency and makes the case that using it leads to faster learning curves. Duolingo has users by the lapels in terms of meeting daily quotas and maintaining performance streaks. Duolingo, on the other hand, releases the user once the daily activities are completed. TikTok, on the other hand, teases users this stay by offering an effectively endless menu of consumable media. Duolingo's consumers are willing participants in a daily regimen, Bain said. But you're almost definitely unaware that their ads and use statistics are part of much larger ecosystem. I believe TikTok's consumer, particularly the younger ones, are blissful naive of the strategies and consequences of their actions. Corporate ownership of personal data. With the advancement of devices and software, AI-based processing of biometric and other contextual data on clients has expanded tremendously. Users can be profiled and their habits predicted in frightening detail by software. Most of the time, the ethical concern is what to do with the data, said Miguel Lopez, Vice President of Product Line Management at Video, a video conferencing platform. This ethical dilemma affects developers in all types of business, not just the social media behemoths that make headlines. The information gathering and profile building are directed by an algorithm, but the subsequent actions are deliberately, and the developer is usually conscious of the power of this data in context. According to Lopez, one of the fundamental reasons for ethical concerns is the way the company earns revenue and incentivizes developers and business managers. In many circumstances, business regard user data as a valuable commodity that they want to monetize. These factors may lead the companies to divulge their users' data in an immoral manner, Lopez warned. When it comes to personal data and software design, developers must make a difficult choice. They can either build tools to exploit user data with the understanding that the organization bears the responsibility, or they can express concerns but risk being penalized for going against the project's goals. Developers should be able to come forward with concerns about personal data ownership without fear of punishment in today's technology businesses. These kinds of issues spark a lively debate at Video, which ultimately chose not to offer a free service tier. We've looked into the consequences and decided that instead of selling our user data, we'd rather sell our service and avoid putting our developer team through these difficult decisions, Lopez stated. Internally, the organization has discovered that transparency is critical. Developers should understand the overall context of the project they're working on. Not just the module they're working on, developers should be able to voice their concerns easily. The HR department may set up channels that allow developers to voice their concerns without fear of punishment, such as an anonymous hotline for ethical problems. Following that, the company should investigate and determine whether the use case violates any privacy, legal, or ethical laws. Algorithm bias. Existing biases can be amplified by technology. Bias is one of the most pressing ethical concerns facing today's developers, said Spencer Lentz, principal Capgemini's AI and Digital Process Automation's Digital Customer Experience. Bias frequently sneaks into the system undetected. Bias, according to Lentz, is like a virus. Computers do not have a built-in moral framework. Only the training that is given to software can be learned. As a result, developers and data scientists must remove bias from training data algorithms. From the standpoint of a developer, bias typically entails ruling out solutions for the wrong reasons. According to Lentz, recent reports and research have shown how software prejudice can be perpetuate systematic racism against specific demographics, resulting in lost opportunities. Worsen medical care. Recent reporting and research have shown how software prejudice can perpetuate systematic racism against specific demographics, resulting in lost opportunities, worsened medical care, and higher incarceration rates. Ruha Benjamin, for example, highlighted concern in her book Race After Technology about an instance in which developers refuse to incorporate Black people's voices in training AI speech recognition algorithms ostensibly because they believe the app would be used less by Black people. Practices must be intentional about their work, asking questions like how was this data acquired and what assumptions were collected with it. To avoid bias in data models, Peter Wang, CEO and co-founder of Anaconda said, if you don't know how and under what conditions the data used to train your models were acquired, data scientists and engineers must construct an organizational culture that defines ethical rules and enables employees at all levels of the firm to speak up if they observe something that isn't right. One recommendation what a regulating body be established into the American Medical Association for Doctors. This body might be set ethical standard and best practices for the entire industry. These technologies are still relatively new in the corporate setting, and rather than leaving it up to each individual or company to decide for themselves, he said, we would all benefit from the ethical norms established from our collective intellect and contribution. Weak cybersecurity. As software plays a larger role in both online and offline settings, application security is becoming increasingly important. Rather than addressing security during development, developers frequently do so after the code has been released. As a result, there are no secure development standards in software community. Almost everything is focused on getting a product to market, said Randolph Morris, CEO of Bit Developers, a software development firm. Once a software product is out to the public, the attention switches to new features and performance optimization, and security takes a backseat. Hackers and other nefarious actors inflict serious harm on actual individuals. Our existing digital ecosystem addresses application security by patching flaws when they are discovered. It is neither feasible nor pragmatic to take a reactionary stance. Developers require education to meet this ethical duty for client safety, but these subjects are often covered solely in cybersecurity-related seminars. To begin, inform your employees about cybersecurity breaches like the Anthem medical data breach in 2015, in which personally identifiable information was kept in plain text in a database. This information would not have been as easy to use and share if had been encrypted, Morris said. In addition, the sector requires updated security standards. Organization may do more to embrace PII protection guidelines. The Payment Card Industry Data Security Standard and HIPAA for health apps are fantastic places to start. But developers should also think about additional types of PII and how to safeguard them in software. Overemphasis on features. Many ethical difficulties revolve around the conclusion that the capabilities of software releases are more essential than the potential consequences. However, just because you can doesn't mean you should. If a developer team's velocity of feature creation assess, there's a good chance that the ethics of a specific implementation won't be top of mind, either during the design or implementation phase. Team Mackey, Principal Security Strategist at Hypnosis Cybersecurity Research Center, stated, Sypnosis is a firm that is specialized in electronic designs. The company, Design Automation. The company must set the tone in terms of ethical software standards. From design to operation, keep ethics in mind. Staff members should be educated on ethical issues including open source software license and usage. Teach data management procedures that meet with rules and consumers' expectations to developers, architects, testers, and other software team members. According to Maki, developers don't keep up with the newest legislation developments in the areas where their software is used. But the company must make sure they are. Engineering, leadership, and legal teams working together can help to avoid ethical blunders. Consumers' personal data access and retention, for example, should be prioritized by the firm. During the software implementation process, data access, controls, and logging systems are implemented. Data access limitations will be viewed as a duty of another team by the developer tasked with developing a working, user-friendly product. Rather, make data protection in a built-in element of the software, which protects against unwanted access from the start.
Why software quality is important. Software system, like any other product, must be of high quality. It is a software company's obligation to offer a quality software product that is well tested for flaws and vulnerabilities. Whether it is be a basic internal system for a few individuals or a software product that caters to millions of customers. Basically, if quality yung software product, mas better at easy to manage. Yung ethical decision naman, there are certain foundation that the developers need to make appropriate ethical decision when faced with difficult situation. May tatlo nun, yung systemizing, defending, recommending concept. Systemizing, developer must organize data needed in software development in order to implement ethical decision. In defending, it was created to ensure that a piece of software will continue to work in the event of a disaster. Yung recommending naman, recommending concept, based on the information provided, hindi na siya as a conclusion lang, para na siyang result na rin. Ganun. Yung significant impact, ethical decision is software development have a significant impact on end users. Developer ensure na walang nagiging problema yung user's application na ginagamit niya. Organization, ang important ng software sa organization, kaya mas okay na yung developer is di magkamali at palaging okay yung ethical decision na ginagamit niya. Yung environment naman, if nagka-issue at nabago yung ethical decision ng developer, it also affected the software. Kasi yung software has a significant impact of resource at efficiency of IT hardware and how long it lasts.
Strategies to improve software quality. A software development strategy is a set of upfront decisions that enables you to developer to come up with an effective set of do's, don'ts, and hows for future application designs, development, and deployment, as well as progress consistently through each step of the development process. Here are some of the effective strategies to improve software quality. Number 1. Test early and test often with automation. To improve software quality, it is absolutely paramount to test early and test often. Early testing will ensure that any defects do not snowball into larger, more complicated issues. The bigger defect, the more expensive it becomes to iron out any issues. The earlier you get your testers involved, the better. It is recommended to involve testers early in the software design process to ensure that they remain on top of any problems or bugs as they crop up, and before the issues grow exponentially, which generally makes it harder to debug. Number 2. Implement quality controls from the beginning. Testers can monitor quality controls and create awareness in partnership with developers to ensure standards are continually being met. Quality control starts from the beginning, which is an ongoing process throughout the delivery. A good relationship between testers and developers can help the project software strategy develop effectively. A systematic methodology in quality control can ensure that coding errors and bugs are dealt with effectively. With the following a structured process. Number 3, echo the importance of quality assurance through the entire software development process. Quality assurance should be ever present throughout the software development process. Quality assurance is a governance provided by the project team that instills confidence in the overall software quality. Assurance testing oversees and validates the process used in order to deliver outcomes have been tracked and are functioning. Testing should be repeated as each development element is applied. Think of it as layering a cake. After every layer is added, the cake should be tasted and tested again. Number 4, encourage innovations. It is important that testing structures and quality measures are in place. However, there should be always be room for innovation. A great way to allow innovation is to automate testing where possible to minimize time spent on controls. Innovations are so important because they can lead to improvements in software quality that they have the capability to transform how projects are delivered. Research and development should be encouraged. Empower teams to explore, experiment, and investigate continuously. Also ensure that advancements in innovation are duly rewarded. They have the capability to transcend your software quality and deliver projects with a competitive advantage over the competition. Number 5. Communication is the key. To improve software quality, it is important that all the parties to the project have full information through fluid communication channels. Fluid communication can take many forms. It can be as simple as having clear consistency KPIs that show how software quality is measured at every step of the development process. It is important that all team members, regardless of seniority, have access to KPIs to keep the entire team on the same page. Another important aspect of fluid communication is all the parties have the opportunity to provide feedback to the team to ensure that all expectations are met. It is also important to keep all stakeholders in the loop and not isolate team members from the vendors or end user of the software. Isolation can cause lips and can often mean the project is delayed or may not deliver on the goals expected by senior management. Number 6. Plan for changeable environment. Software contains so many variables and it continuously evolution. It relies on several different external factors such as web browsers, hardware, libraries, and operating systems. These constant external factors mean that software development must be consistently monitored using checks and balances to certify that it remains to stride with its immediate environment. It is important to acknowledge the software is interdependent. On these external factors, accepting this interdependence means that you can plan ahead. It always you to have the software quality tested at each step of the process against external variables to see how it holds up. The end result is that you will prevent software discounts and maintain software quality.
Take the attitude of creating products, not project. This step is reflection of the attitude of your team. Creating a project indicates to your team that you are producing a finite outcome. However, you are well aware that software is changeable. If, if you produce finite outcome, before long the software quality will not stand up against its environment. Instead, if your team takes the mindset that they are creating a product, it is more likely that they will deliver software quality that it's adaptable to change and can stand the test of time. Focus on delivering continuous small progression rather than one final end project and your team will deliver an increase in quality. Have a risk register. A risk register is a fantastic management tool to manage risk. A risk register is more synonymous with financial auditing, however, it is still a vital element in software development. A risk register will provide everybody aligned on a software project a list of clearly identified risks and then assist them in regards to the importance of delivering the project. A risk register works well from software quality because its creation actively leads to risk mitigation. Producing software quality requires long-term thinking and strategy. Long-term thinking produce software quality because decisions are made to satisfy lasting issues. Outline your deliverables. From the outset of your project, it is imperative that your team outline what they are going to deliver. A clear and concise plan of what the project will deliver helps ensure there is an emphasis on quality from the outset. It also ensures that the budget, resources, and time are aligned correctly to deliver quality. Without clear deliverables, it is likely shortcuts will be taken to meet budgets and deadlines. Ultimately, this will compromise the quality of the software delivered at the end of the projects. Review, revise, and remember. Producing software quality is not a coincidence.
Waterfall System Development Model. The Waterfall System Development Model is a multi-stage, sequential system development approach in which the next stage of the system cannot be developed until the current stage outcome has been accepted or updated as needed. There are six different phases of waterfall model. Number one is requirements. Requirement is the first phase involves understanding what needs to design and what its function, purpose, etc. Here, the specification of the input and the output or the final product are studied and marked. Number two is system design. The system design is the requirement specification from the first phase are studied in this phase and the system design is prepared. System design helps in specifying hardware and system requirements and also helps in defining overall system architecture. The software code to be written in the next stage is created now. Number three is implementation. Implementation with inputs from system design. The system is first developed in a small program called units, which are integrated into the next stage. Each unit is developed and tested for its functionality, which is referred to as a unit testing. Next is integration and testing. All the units developed in the implementation phase are integrated into a system after testing of each unit. The software design needs to go through constant software testing to find out if there are many flaws or errors. Next is development of system. Once the functional and non-functional testing is done, the product is deployed in the customer environment and released into the market. Lastly is maintenance. This step occurs after installation and involves making modifications to the system or an individual component to alter attributes or improve performance. This modification arises either due to a change request initiated by the customer or the defects uncovered during life use of the system. The client is provided with regular maintenance and support for the development software. Agile System Development Model. When using this model, a system is developed in iterations, often called sprints, lasting from 1 to 4 weeks. The division of the entire project into smaller parts help to minimize the project risk and reduce the overall project delivery time requirements. Each iteration involves a team working through a full software development life cycle including planning, requirements analysis, design, coding, and testing for the working product demonstrated to the client. Those phases of Agile are requirements gathering. In this phase, you must define the requirements. You should always explain business opportunities and plan times and effort needed to build the project. Design and requirements. When you have identified the project, work with the stakeholders to define requirements. You can use the user flow diagram or the high-level UML diagram to show the work new feature and show how it will apply to your existing system. Construction or iteration. When the team defines the requirements, the work begins. Designers and developers start working on their project, which aims to deploy a working product. The product will undergo various stages of improvement, so it includes simple, minimal functionality. Testing. In this phase, the quality assurance team examines the product performance and look for bugs. Deployment. In this phase, the team issues the product for the user's work environment. Lastly, feedback. After releasing the product, the last step is feedback. In this, the team receives feedback about the product and works through the feedback. Quality assurance. Quality assurance refers to a measure used during the development process to ensure a product's reliable operation. Quality assurance is a systematic process of determining whether a product or service meets specified requirements. It also establishes and maintains set requirements for developing or manufacturing reliable products. A quality assurance system is meant to increase customer confidence and company's credibility, while also improving work process and efficiency, and it enables a company to better compete with others. Quality assurance helps a company create products and services that meet the needs, expectations, and requirements of customers. It yields high-quality products, offering that build trust and loyalty with customers. The standard and procedures defined by quality assurance program help prevent product defects before they arise. These are the three quality assurance methods. First is failure testing, which continually tests a product to determine if it breaks or fails. For physical products that need to withstand stress, this could involve testing the product under heat, pressure, or vibration. For software products, failure testing might involve placing software under high usage or low conditions. Second is statistical process control, a methodology based on objective data and analysis developed by Walter Shewhart and Western Electric Company and Bell Telephone Laboratories in the 1920s and 1930s. This methodology uses statistical methods to manage and control the production of products. Total quality management, which applies quantitative methods as the basis for continuous improvement. It also relies on facts, data, and analysis to support the product planning and performance reviews.